All right, so are you ready for this? We're going to dive deep into deploying Python Reflex apps on AWS.
Yeah.
But we're not just talking about like any deployment, right?
No, no.
We're talking about running both WebSocket connections on port 3000
Okay.
and having a REST API on port 8000.
Wow.
So, pretty cool stuff.
Yeah, very cool.
And to guide us, we have some really great material from a technical guide all about deploying these apps.
Sounds good.
So our goal today is to make this super clear,
Right.
cut through all the jargon,
Right.
and give you a clear roadmap to actually deploy this.
Awesome.
So let's get started.
Okay.
Before we even touch AWS, what are the absolute essentials we need ready to go?
Well, first off, you're going to need an active AWS account.
Makes sense. That's our playground.
Exactly.
Okay, what else?
Well, then you'll need a well-configured Python environment all set up.
Okay, with our Reflex app ready to go?
Of course, of course.
Anything else?
You'll need the AWS command line interface, or CLI for short,
CLI, okay.
to actually interact with AWS from your terminal.
Got it.
And lastly, we'll need an EC2 instance.
Okay, so that's kind of like our virtual server out in the cloud where everything's going to live.
Exactly. That's a great way to put it.
Okay, so those ports we mentioned earlier, 3000 and 8000.
Right.
Those need to be open on our instance so traffic can flow in and out.
Yes, exactly.
Kind of like opening the doors to let the right guests into our party.
I like that analogy, yeah.
So we've got our ingredients, doors are open.
Okay.
Now, how do we spin up this EC2 instance?
So we're going to head over to the AWS EC2 dashboard,
Okay,
which is our control panel for all things EC2.
got it.
From there, we can launch a new instance.
And I imagine we have some choices to make when launching this.
You bet we need to pick an Amazon Machine Image,
Okay.
or AMI for short. Basically, it's the operating system for our instance.
So it's like choosing Windows or Mac.
Yeah, exactly like that.
Okay.
And in this case, I'd recommend an Ubuntu server image, like Ubuntu 20.04 LTS.
Okay, why not one?
It's known for being very user-friendly and well-suited for this.
All right, so it's like picking the right operating system for our spaceship.
Exactly.
Got to support the mission.
Exactly.
Okay, cool.
And we also need to choose an instance type.
Okay.
This is all about the computing power and memory our instance will have.
So like how much horsepower?
Exactly.
Okay.
For testing, a T2 Top Micro instance is a really good start.
Okay, why that one?
It's a good balance of performance and cost, you know.
For testing.
Exactly, for testing.
Gotcha.
Then we can always scale up later if needed.
It makes sense.
Yeah.
So we've picked our operating system, our engine size. What else?
We need to set up a key pair.
Okay.
It's basically a set of cryptographic keys so we can connect to our instance securely.
So kind of like a special key card to access our server?
Yeah, like a digital key card.
Very cool.
And finally, we configure a security group.
Okay.
It acts as a virtual firewall.
A firewall.
Yes, controlling all the incoming and outgoing traffic.
So it's like a security endpoint for our server.
Exactly.
Making sure only the right stuff gets in.
That's a good way to think about it.
So what specific rules do we need to set up in our security group?
We need to allow traffic on ports 3000 and 8000, of course.
Right, those are our communication channels.
Exactly.
Okay, so we've got our instance launch
Yes.
securities in place.
Okay.
What's the next step to get our app running on this EC2 instance?
Now we equip our server with the tools it needs.
All right, I like it.
First, we update the server's software,
Okay.
make sure everything's running the latest versions, security patches and all that.
So it's like downloading the latest upgrades.
Exactly, exactly.
Okay.
And then we'll install all the dependencies,
Okay.
Python, pip, the WebSocket library, and Flask.
Okay, and remind me what Flask is again?
It's a framework for building web applications in Python.
Gotcha. So we've got the foundation, the communication system, the power generator,
Right.
everything our server needs to run our app.
Yeah, it's all coming together.
Server prepped, tools installed, what's next?
Now for the heart of it all,
Okay,
the Python Reflex app itself.
here we go.
We need to get that running on the EC2 instance.
All right, how do we do that?
So we've got a couple options.
Okay.
We can upload the app using SCP.
Secure copy, right?
Exactly.
there.
Or if it's just a small script, we could just copy and paste the code directly.
Right into the terminal.
Exactly.
So it's like beaming the software straight to the server.
Yeah, I like that, beaming it up.
All right, and then once the code's there,
Then we need to navigate to the right folder
okay,
and then run the command python3 app.py.
okay.
That fires it up.
And that's it. Our app is live.
Almost. We got to double check the security group.
Right. Got to make sure those doors are still open.
Exactly.
So how do we do that?
Head back to the EC2 dashboard,
Okay,
go to security groups,
okay.
and verify we've got the right inbound rules.
For ports 3000, 8000, and 22.
You got it.
Okay, so security's confirmed.
Okay, good.
How do we actually access our application?
So for the WebSocket server, you would use ws.3000,
Okay,
replacing that with your server's public IP address.
got it.
And for the API, you'd visit http.8000.00 API in your browser.
With the same IP address.
Right, same IP.
Okay, amazing. So our app is up and running,
It's alive.
ready to handle those WebSocket connections and API
Yep,
requests.
ready to go.
But this is just the beginning,
Yeah,
right?
yeah,
There's
absolutely.
so much more we can do
This is just the foundation.
to make this deployment even better.
We can take it to the next level.
All right, well, let's take a quick break and then we'll come back and talk about all that.
Sounds good.
Okay, so we've successfully launched our app, but
Yeah.
as we hinted at before, there's so much more we can do to take this deployment
Oh, yeah.
to the next level.
Absolutely.
Like really unlock its full potential.
Yeah, exactly.
So let's talk about optimization.
Okay.
Like, how do we fine-tune this setup for maximum performance security,
Yeah.
and even cost effectiveness?
All the good stuff.
Where do we even begin with this?
Let's start with performance.
Okay.
We want our app to handle a lot of users,
Of course.
a lot of requests,
Right.
without slowing down.
Right. It's like making sure a website doesn't crash when it gets a ton of traffic.
Exactly, exactly.
So how do we boost performance in our AWS deployment?
One really powerful tool is a load balancer.
Okay.
AWS has this service called Elastic Load Balancing,
Okay.
or ELB.
ELB. Okay.
It can distribute incoming traffic across multiple EC2 instances.
So instead of all the traffic hitting one server,
Right.
we can spread it out
Yeah.
like a team of servers.
Exactly. And this not only improves performance,
Right.
but it also increases availability.
Okay, how so?
Well, if one server goes down,
Uh-uh.
the load balancer just redirects traffic to the other healthy servers.
Seamlessly.
Exactly. Users won't even notice.
That's pretty impressive.
Yeah.
So how do we set up a load balancer?
It's easier than you think.
Okay, good.
We can configure it using the AWS Management Console,
Okay.
the AWS CLI, or even Terraform.
Oh, right. Infrastructure as code.
Exactly.
We'll get to that later.
Yeah, we'll dive into that.
But for now,
Right.
with the load balancer, we'll specify the type,
Yes.
the ports, which are 3,000 and 8,000 in our case,
Right.
and the EC2 instances that should be in the target group.
Exactly. You got it.
So we basically just tell the load balancer, hey, here are the servers.
Yeah.
You figure out how to distribute the traffic.
You got it. It's the traffic cop.
Perfect. What else can we do?
Another key area is caching.
Catching. Okay.
It can really boost performance by storing frequently accessed data in a fast, readily available location.
So it's like keeping a copy of a file on your desktop
Right.
instead of digging through folders every time.
Exactly. Saves you a ton of time.
So how do we implement caching in our app?
AWS has a service called Elasticache.
Okay.
It provides managed caching solutions using Redis or Memcached,
Okay.
and we can integrate that into our app
All right.
and configure it to cache things like database query results
Okay.
or API responses,
Gotcha.
which reduces the load on our back end.
Makes things faster.
Everything feels snappier.
I like Snappy.
Yeah, who does?
Okay, caching. Check. What about our database?
Yes, the database.
Any room for optimization there?
Absolutely. If our app uses the database a lot,
Right.
we want to make sure it's tuned for performance
Okay.
and scalability.
Scalability.
Yeah.
Okay.
Instead of managing our own database server,
Right.
we can use a managed service like Amazon RDS
RDS. Okay.
or DynamoDB.
DynamoDB.
These services handle all the backups, replication, scaling,
All that stuff.
all the nitty-gritty details.
Can focus on the app itself.
Exactly. Frees up your time.
Perfect. So it's like having a dedicated team of database experts.
Yeah, that's a great way to think about it.
Okay, so we've got performance, the database. What about keeping things running smoothly?
Right. We can't forget about monitoring and logging.
Essential for any production deployment, right?
Absolutely.
Okay.
We need to keep an eye on performance,
Right.
detect issues quickly,
Right.
and have all the info we need to troubleshoot.
So it's like having a set of sensors
Yeah.
constantly monitoring our systems.
Exactly.
Okay.
And luckily, AWS provides some great services for this.
Oh, good.
CloudWatch lets us collect and track metrics,
Okay.
set alarms.
But like if something goes wrong.
Exactly.
Okay.
And we can even visualize how the app's performing over time.
So we can see CPU usage, memory, all that stuff.
Exactly. It's like a health report for your application.
Perfect.
And CloudTrail provides audit logs of all API calls,
Okay.
which is great for security and compliance.
So we know who did what and when.
Exactly. Full transparency.
And what about X-ray?
Oh, X-Ray's awesome.
What does it do?
It gives you deeper insights into how your app is performing.
Okay.
It traces requests as they flow through different parts of the app
Okay.
and pinpoints any bottlenecks.
So it's like X-ray vision into our application.
Yeah, I like that.
Seeing how everything is working together.
Precisely.
Very cool.
It's a powerful tool.
Okay, so performance optimization, database optimization, monitoring.
Yep.
Anything else we need to think about?
Well, we can't forget about security,
Of course, security is paramount.
especially in the cloud.
Right.
But luckily, AWS offers a lot of tools and services to help us out.
Okay, good. What are some key things we should do?
First, lock down that EC2 instance.
Okay.
Strong passwords, multi-factor authentication,
Okay.
keep the operating system and all software up to date.
Right. All the security patches.
Exactly. Can't forget those.
So it's like making sure our spaceship have the latest defense systems.
I like that analogy.
Okay. Secure EC2 instance. What else?
We need to configure those security groups really carefully.
Right. Only allow the traffic that's absolutely necessary.
Precisely. It's like controlling access to our spaceship.
Only let the authorized personnel in.
Exactly.
Okay, what else can we do?
AWS Identity and Access Management,
Okay.
or IAM.
All right.
It lets you control who has access to your AWS resources.
So different security clearances for different crew members.
Yeah, that's a good way to put it.
Okay, cool.
And for sensitive data, we should use encryption.
Encryption, right.
It scrambles the data.
Makes it unreadable.
Unless you have the decryption keys,
Okay.
which we can manage with AWS Key Management Service.
Or KMS.
Yep, KMS.
So even if someone intercepts our data, it's useless without the key.
Exactly. It's like a secret code.
And a lot of AWS services have built-in encryption, right?
Yes, like S3 for storage and RDS for databases.
So it's easy to implement.
Yep, they made it pretty straightforward.
Perfect. Security sounds airtight.
As airtight as we can make it.
Anything else on the security front?
Last thing, we need an incident response plan.
Okay, so if something happens,
Right, if there's a breach.
despite all our precautions,
Exactly.
we know what to do.
Exactly, a clear protocol.
Contain the damage, recover quickly. So we need procedures for detecting, containing, and recovering.
Yes, and AWS services like GuardLady and SecurityBub can help with that.
Perfect. So security is covered, performance optimization, database optimization, monitoring.
It's all coming together.
Anything else we can do to fine-tune our deployment?
Well, we can't forget about cost optimization.
Oh, right, saving money.
Everyone loves saving money.
So how do we optimize costs in AWS?
One thing is choosing the right EC2 instance size.
Right, we started with the T2.micro for testing,
Exactly.
but in production we might need to scale up.
Right, you might need a bigger instance.
But how do we know what size is right?
AWS has tools like Trusted Advisor and Cost Explorer.
Okay.
They can analyze your usage and find areas where you might be overspending.
Or underutilizing.
Exactly.
So it gives us recommendations.
Right, tailored recommendations.
Okay, what other cost-saving tips do you have?
We can look into reserved instances
Okay.
or spot instances.
For certain workloads?
Right, for more flexible workload.
Okay.
Reserved instances let you reserve capacity for 1 or 3 years
Okay.
at a discount.
So it's like pre-booking a hotel room.
Yeah, exactly like that.
Okay.
And spot instances let you bid on spare capacity.
Okay.
It could be way cheaper.
Up to 90% cheaper, you said?
Yeah, it could be a steal.
But there's a catch.
Right, your instance could be terminated.
The price goes up.
Exactly. It's a bit of a gamble.
So reserved instances are better for steady workloads.
Right.
And spot instances are for more flexible tasks.
Exactly.
Okay, cool. So we've covered performance, database, monitoring, security, and even cost optimization.
We've hit all the major points.
Is there anything else we should keep in mind?
Just one final thought.
Okay.
Always be learning
Oh, yeah.
and experiment.
In the cloud.
Yes, the cloud is constantly evolving.
New services, new features.
All the time.
It's like the galaxy's expanding.
I like that, the cloud galaxy.
So as we wrap up, what are the key takeaways here?
The main points to remember are use a load balancer, leverage caching,
Yeah,
consider a managed database,
right.
implement strong monitoring and logging,
Of course.
prioritize security,
For all you.
and explore cost optimization.
Got it.
Make the most of your AWS resources.
That's a great summary.
And
remember, this is just the beginning.
oh yeah,
There's so much more to
a
learn.
whole universe of possibilities.
In the next segment, we'll dive into some of those advanced techniques,
Sounds good.
pushing the boundaries of what's possible with Python Reflex apps on AWS.
Can't wait.
All right, welcome back to the deep dive. We've covered so much.
We have.
From the basics of deploying a Python Reflex app
Right.
to optimizing for performance, security, you name it.
All the good stuff.
Now it's time to get a little bit more advanced.
Okay.
Explore some techniques that can really take things to the next level.
All right. I like it.
We're talking containerization, serverless computing, infrastructure as code.
The big guns.
It's getting exciting.
It is.
So let's start with containerization.
Okay.
I keep hearing about Docker.
Right.
What is it exactly?
Docker is a platform that lets you package your app
Okay.
and all its dependencies.
Everything it needs to run.
Exactly.
Okay.
Into a container.
A container. Okay.
It's portable, self-contained.
So it's like taking our entire spaceship,
I knew you were going to say that.
putting it in a standardized cargo container.
Yep, exactly.
We can ship it anywhere.
Exactly. Consistent and portable.
I love it. So how do we Dockerize our Python Reflex app?
So we start with a Docker file.
Docker file.
It's basically a set of instructions to build a Docker image.
Gotcha.
In the Docker file, we specify the base image,
Okay.
which has the operating system and dependencies.
Okay.
Then we had our code, install libraries, and define how the app starts up.
So it's like a blueprint for our spaceship in a container.
Exactly. You got it.
What will we do with the image once it's built?
We store it in a container registry.
Registry. Okay.
It's a place to manage Docker images.
Okay.
Amazon has a service called Elastic Container Registry.
ECR.
ECR, yep. That's a good option.
So it's like a hangar for our containerized spaceship.
You're really sticking with that analogy.
I like it.
Okay, so we built the spaceship, parked it in the hangar.
How do we launch it?
This is where Amazon Elastic Container Service comes in.
ECS?
ECS, it's a managed container orchestration service.
Orchestration, so it manages our containers.
Exactly. Deploys them, scales them.
Makes it easy.
Exactly.
So ECS is like the control tower guiding our spaceship
I like it, yeah.
through the cloud.
Right.
Okay, so how do we use ECS?
We define a task definition,
Okay.
which tells ECS what image to use,
Okay.
how much CPU and memory it needs.
It's like setting the launch parameters for our spaceship.
Exactly.
And then we deploy the containerized app using an ECS cluster.
Right. An ECS cluster is a group of EC2 instances.
Managed by ECS.
Yes.
Okay.
We launch our app as a task on the cluster.
And ECS handles everything.
Scheduling, running, monitoring.
It's like the autopilot.
Yeah, keeping everything running smoothly.
And we can even scale our app automatically with ECS.
Absolutely. Based on demand.
It's amazing. Docker and ECS sound incredibly powerful.
They are, especially for large-scale deployments.
Okay, what else can we do?
Let's talk about serverless computing.
Serverless, that sounds futuristic.
It is. It's a whole different way of thinking about things. You run code without managing servers.
How is that even possible?
AWS Lambda is a great example.
Lambda, okay.
It's a serverless computing platform.
So it's like beaming our code to AWS.
And it just runs.
Without us worrying about servers.
Exactly.
That sounds way too easy.
It's pretty amazing.
So with Lambda, we write functions that are triggered by events.
Right, like an HTTP request or a file upload.
Okay.
And each function runs in a scalable environment managed by AWS.
So we don't have to manage anything.
Nope, AWS takes care of it.
Can we run our entire Python Reflex app as a Lambda function?
It might need some tweaking,
Okay.
but it's definitely possible. We could create separate functions for WebSockets and the API.
Okay.
And use API Gateway to route traffic.
So it's like breaking down our spaceship into smaller modules.
Exactly. More flexible and scalable.
And the best part,
What's that?
you only pay for what you use.
Oh, yeah. That's a huge benefit.
Especially if traffic is unpredictable.
Absolutely.
Serverless computing is pretty amazing.
It is. A real game changer.
Okay, what other advanced techniques are out there?
Let's go back to infrastructure as code.
IAC, right?
Yeah.
We talked about Terraform earlier.
Right.
But there's also CloudFormation.
AWS CloudFormation, yeah.
Remind me why IAC is so important.
It lets us define our entire infrastructure as code.
Servers, networks, everything.
Everything, all in code.
And that's good because...
Deployments become repeatable,
Okay.
version controlled, auditable.
We can track all the changes.
Exactly, and collaborate with others easily.
So it's like having a detailed blueprint for our spaceship.
That's a good way to put it.
Everyone's on the same page.
Exactly.
And we can automate the entire deployment pipeline?
From building the app to deploying the code.
Wow, IA sounds essential for complex deployments.
It is. It really simplifies things.
So as we wrap up this deep dive,
Yeah.
any final thoughts?
Embrace the cloud mindset.
Cloud mindset, I like
The
it.
cloud is so powerful.
Flexible, scalable.
It's the future.
Don't be afraid to experiment.
Try new things.
Learn new tools, push the boundaries.
That's what it's all about.
Well said. We've covered a ton of ground today.
we have.
From the basics to the more advanced stuff.
Containerization, serverless IAC.
Hopefully our listeners feel empowered to build amazing things in the cloud.
I hope so too.
It's been a great journey.
It has.
Thanks for joining us on the deep dive.
Thanks for having me.
Until next time, keep exploring, keep learning, and keep building.